So now we will study some thermal analysis method, in which one is thermogravimetric analysis. So thermal analysis method are basically measuring the chemical and physical changes which occurred with temperature changes. Okay, so now in this thermal analysis, one method is thermogravimetric analysis. So what is it? It is basically in this method we measure changes in weight in relation to changes in temperature. Okay, so what changes comes when we change the temperature of a sample? So the measured weight loss score gives information of changes in sample composition, thermal stability, kinetic parameters for chemical reactions in the samples. So changes occurred in weight loss when we apply some temperature, either it may be cooling or heating. So the changes we get is in sample composition, thermal stability, and kinetic parameters for chemical reactions in the sample. Yani from changes in the temperature we get these information about the sample composition, the stability, that what extent to it can absorb the heat, and kinetic parameters, that through which rate the chemical reaction happens. Now, a derivative weight loss score can be used to tell the point at which weight loss is most apparent. So we get a curve which is given to us by readout devices like computer. From that curve we can measure different points which tell us different stories. Okay, TGA phenomena causing mass changes. So what are the phenomena occurring in the material when we apply the temperature? That what phenomena causes the loss in weight? One is physical phenomena, the other is chemical phenomena. So in physical phenomena, gas absorption, gas desorption, phase transitions like vaporization and sublimation that are responsible for loss in mass. And in chemical methods we have decomposition, breakdown reactions, gas reaction, chemosorption, absorption by means of chemical instead of physical forces. So these are the different methods which are responsible for loss in mass, for changes in mass. So TGA applications. TGA can be used for the characterization of thermal stability, material purity, and determination of humidity. Okay, so it is a very good analysis method through which we can obtain different information about a particle, like thermal stability, that to which extent it can absorb the heat, material purity. Okay, if we know the material and its core, and then we have an unknown material, and we plotted the curve like that, so we can get information about the purity. Okay, now TGA example, one of the example in TGA which is mostly used is decomposition calcium oxalate monohydrate. Okay, so calcium oxalate monohydrate is standard material upon use to demonstrate TGA performance. Exhibit 3 weight losses with temperature in an inert atmosphere like nitrogen. So this is the chemical reaction in which first the loss of water occur. In another reaction carbon monoxide is lost while another carbon dioxide is lost. So you can see from this reaction that the weight, or there is decrease in weight as the reactions happens. Okay, so now it is the core of that reaction. You can see here clearly that we get peaks at which the mass is lost. Okay, so it is one of the very best technique for studying chemicals. Okay, chemical compositions, for analysis of different chemicals. Now factors affecting the TG curve come there. So heating rate and sample size, the increase the temperature at which sample decomposition occur. Increase the temperature at which sample decompositions occur. Now particle size of sample, packing, crucible shape, gas flow rate affects the progress of other reactions.